Deep in the cosmos, Przybylski's star is surrounded by a fascinating enigma. Its spectrum reveals heavy and short-lived elements, materials that according to natural laws should not be there. These elements usually disintegrate in the blink of an eye. We humans create them in terrestrial laboratories, and in nature they should not exist permanently. And yet there they are, persisting in this star as if someone or something had deliberately placed them there. This mystery does not end with Przybylski. Other stars are also displaying inexplicable behaviors with molecules and chemical compositions that do not fit into the known patterns of the cosmos. Some astrophysicists wonder if new elements are being created through natural processes, or perhaps there is an artificial intervention. But that is not all. We will analyze the end of the periodic table that includes the heaviest elements discovered and others predicted by science. You will see that the forms of life and matter that can be created in this next-generation universe is overwhelming. The James Webb Telescope has detected unexpected molecules in the planet-forming disk around a young star, which was thought to be a single star. WL20S is actually a twin star system. A pair of twin stars formed 2 and 4 million years ago. In addition, the twin stars are accompanied by jets of gas flowing from their poles, a phenomenon that had not been detected until now. James Webb has revealed the presence of long and complex carbon molecules that were not expected in this type of environment. These molecules, known as polycyclic aromatic hydrocarbons, are compounds containing carbon and hydrogen rings, and are usually found in more mature environments, or in warmer areas of space. These complex organic molecules may be precursors to life, since hydrocarbons can be converted into amino acids and other biological compounds under the right conditions. Its presence in a young planetary disk suggests that the basic ingredients for life may be present much earlier than previously thought, even during the earliest stages of planet formation. This finding challenges existing theories about planet formation, the chemistry of space, and reinforces the idea that chemical processes in the cosmos may be much more varied and rich than our current models allow. This could be an isolated case, but it is not. Przybylski's star is one of the most mysterious and fascinating objects in the sky. This star, also known as HD 101065, is in the constellation Centaurus, about 410 light-years away. It is a little hotter than the Sun and has a spectral lapse type and is chemically very peculiar, as it continuously produces very heavy elements from the periodic table. It is assumed that stars are made up of 99% hydrogen and helium, and the remaining 1 to 2% are made up of heavier elements such as carbon, nitrogen, oxygen, neon, and others. But this star has a different composition. Lead, plutonium, and at least 51 different chemical elements have been found. A star that will generate elements heavier than nickel has never been seen before. Only some of them are made in high-energy processes such as supernovae, and others such as plutonium are only made in neutron star mergers, where there are large numbers of free neutrons that can join atomic nuclei and form heavier elements. But the most intriguing thing is that we have not only found plutonium, but other elements so rare that they are considered short-lived and can only be created in a laboratory. It is as if the star were a factory of heavy elements created by an unknown process. When astronomer Antoni Przybylski discovered this star in 1961, he probably never imagined that his name would be associated with one of the greatest mysteries of the universe. To get an idea of how strange this is, imagine finding somewhere in space a piece of steel that is an alloy of iron and carbon. This alloying and treatment process is specific to human technology and industry and cannot be found naturally. The curious thing about Przybylski's star is that it contains very unusual elements. In addition to the typical ones like silicon and chromium, rare and radioactive elements like promethium, actinium, and plutonium have been found. Some of these elements have very short half-lives, which poses a mystery. How can they exist in abundance in the atmosphere of this star? According to Jason Wright, professor of the Department of Astronomy and Astrophysics in the Faculty of Sciences at Everly University of Pennsylvania, the star has a strong magnetic field and rotates slowly at about 3.5 kilometers per second, not much faster than the Sun, which rotates 2.2 kilometers per second. This allows us to observe the chemical composition of its atmosphere very well, and we are practically sure of its composition. The strange thing about all this is that the elements of this star should not last very long, Promethium has a half-life of more than 17.7 years, but later analysis has found actinium, protactinium, neptunium, americium, curium, berkelium, californium and stenium. They are so rare that they are not found in nature. Not even the most energetic supernovae can create such a quantity of elements. It is as if we had before us an artificial laboratory that is continually creating unknown elements. The star is only 57 million years old. Any radioactive element with a short half-life should have disappeared long before the star reached its current age. What really puzzles us is that many of its elements can only be produced by particle collisions at CERN, through controlled processes. Einsteinium, for example, was created during the detonation of the hydrogen bomb. That is, it is a synthetic element, and only produced by humans, and yet it has been detected in this star. Californium is another synthetic element, and we created it by bombarding curium-242 with helium ions, and it has a lifespan of 2.6 years. So what is going on? It is not understood what all these synthetic elements with short lives do on astronomical time scales in this type of star. The creation of new elements in the universe usually involves highly energetic processes. The difference between one type of element or another lies in the number of protons in the atomic nucleus. For example, hydrogen, the lightest element, has only one proton in its nucleus, while iron, which is heavier, has 26 protons. In a supernova, the energy released is so great that it causes the destruction of atomic nuclei and the release of protons and neutrons. These protons and neutrons combine to form new elements in a process known as the rapid neutron capture process. In this context, heavier elements are formed from lighter nuclei under extreme conditions. But Przybylski's star is not in a supernova phase. Instead, its peculiar chemical behavior could be due to less understood mechanisms. We have many exciting ideas that can change all the schemes of current physics. External source, natural or artificial. There is an external source. It could be that something or someone like a nearby star or even an advanced civilization has added these elements to the star. Internal generation, or maybe the star is creating these radioactive elements in some as yet unknown way. The most plausible hypothesis is that this star could be generating stable radioactive elements that we have not discovered yet, which would be longer lasting and could explain the presence of these radioactive elements. It has been proposed that there is a companion neutron star that bombards the atmosphere of the Przybylski star with particles. This would cause nuclear reactions and the elements that we observe, but we have not found such a star. This leads us to another even more fascinating explanation. As we move up the periodic table, we have heavier and heavier elements, and that also causes instability and short life. However, some theoretical physicists have predicted an idea in nuclear physics called an island of stability, meaning that there are other ways for protons and neutrons to organize themselves in shells and make atomic nuclei stable. Today, the heaviest known element is oganesson, with 118 protons. It is synthetic and highly unstable. It has been speculated that atomic nuclei with more than 118 protons could exist and remain stable for millions of years. After all, nature always seeks stability, and what survives prevails. What does this mean? We could be witnessing one of the strangest phenomena produced in the same and future of the universe. Imagine if the universe in the future contains many more complex and heavier elements. Elements such as californium and promethium have special properties that could give rise to new types of materials with unique characteristics, such as high radioactivity or special magnetic capabilities. If life existed in this new universe, it would be life adapted to radioactivity, with very special capabilities. Biological chemistry could be much more diverse, based on rare elements with unusual chemical properties. Biology would include adaptation on extreme planets, crystalline life forms, and almost like a biomachine. In addition, the presence of elements with more properties could promote the development of advanced technologies that we cannot even imagine. If in the future stars as rare as Przybylski's star are common, the human being would remain as a relic, a simpler form of life created when the cosmos was less complex. We would be like a bacteria for the civilizations of the future, simpler, but interesting. How far can the universe go in complexity? As new elements are created, The nuclei are so large that they cannot remain stable, due to the repulsion forces between protons. It is believed that at some point it will not be possible to create elements beyond a certain limit, and this is because the nuclei will not be able to exist in a stable manner. Even for a few moments, the search for these elements leads to unknown territory. There is no known limit in the periodic table of the elements. But there are strong indications that there could be a practical and theoretical limit beyond which the atomic nuclei would no longer be stable. For now, the periodic table is still slowly expanding, reaching into uncharted territory. Some have even speculated that these unusual elements in the star could be a sign of intelligent life. There are two scenarios. The first is that advanced civilizations could be dumping materials or waste products into the atmosphere of a star. It would be as a means of disposing of radioactive waste just like we do. The star could be being used as a natural laboratory to experiment with the formation of elements under stellar conditions. Carl Sagan and other scientists have suggested that advanced civilizations could intentionally add rare elements to their stars to attract attention. Although this theory is intriguing, it remains highly speculative. Personal conclusion. What we are discovering is simply incredible. Evolved chemical formations in protoplanetary disks, unknown elements in stars, and others that could only be created by artificial processes. And this shows us the great chemical diversity, wonderful and dazzling, of the cosmos. My personal opinion is that the universe is evolving and many natural processes are still unknown. The universe is becoming more complex. After all, we are part of the universe that has reached consciousness, and our artificial creations are only processes of the same natural laws. They teach us how atoms can join together and create a wonderful diversity. I wonder what other life forms with special capabilities and exotic materials can be created in the great cosmic machinery. Perhaps, in some distant world, there are creatures that see the universe with senses that we cannot even conceive, building their own forms of technology and life from exotic materials that for us would be indistinguishable from magic.
Hush.